This is Rob Robles, Product Marketing Manager in the Vision Products Business Unit. The purpose of this video is to provide a very high-level overview of how to set up an Insight 2000 series vision sensor using Insight Explorer 521 and Insight EasyBuilder. Detailed hands-on training and e-schools for the Insight 2000 will be provided in the coming weeks and months. But in the meantime, by watching this video, those of you who have little or no experience using Insight Explorer and EasyBuilder can get a head start on learning how to use the Insight 2000. And for those of you who are already familiar with Insight EasyBuilder, well, you might learn a thing or two that will help you become an Insight 2000 expert in no time at all. So with that, let's get started. This is Insight Explorer. When you launch Insight Explorer for the first time, it comes up in EasyBuilder view. And in EasyBuilder view, you'll have a series of application steps along the left-hand side here. And you'll configure these steps to set up the inspection application on the 2000. However, I'm not actually connected to 2000, and so everything is grayed out with the exception of the Get Connected step. So let's take a look at that. When Get Connected is selected, down in the lower left, you'll see a list of all the Insight systems and Insight sensors that are available on the network. You'll also see your Insight emulator if it's enabled on your PC. If there's an Insight sensor that you're looking for that's not listed here, you can click the Add button to add it manually. My sensor is connected to my laptop, and so I can go ahead and click the Connect button. And now we see the image from the Insight 2000. On the left-hand side, all the application steps are now enabled. Surrounding the image is a border. This will be green or red depending on whether the inspection passes or fails. Of course, I haven't added any tools to my job yet, so the inspection passes because there's nothing to do. Over on the right, in the Palette Results tab, you'll see all of the tools that get added to the job will be listed here, as well as their pass-fail status. So I'll show you that shortly. If I want to open a job, an existing job, I can do that here. If I want to overwrite the job and create a new job, I can click New Job. But we're starting from scratch here, so I'll go ahead and get started. The first step would be to improve my image. It's a little out of focus, so I go to the toolbar and click the Live Video button. Now, in live mode, I can adjust the focus on the 2000. This is the screw that's on the light module. Using a flathead screwdriver, I can adjust the focus until the image is in focal range. There's a nice little feature on the view menu here called the focus metric. When I enable the focus metric, you'll see a bar, a green bar below the image, and as you turn the focus adjustment screw, that bar will get shorter or longer depending on whether you're getting out of focus or in focus. As you can see here, I've defocused the camera. That bar gets short. As I get back into the focus range, the bar increases in length until I get into a focused image, and the bar is pretty stable. Now you can ignore the numbers there. They're pretty much meaningless for most users. Just look at the green bar and where it's positioned at, and that'll help you get the image in focus. So at this point, I'll go ahead and take it out of live video mode, and I'll move on to the Setup Image step. Now the Setup Image step essentially controls how the Insight 2000 will acquire images and when it will acquire images. And the first part of that is to specify the trigger. By default, the job is set up to use a continuous trigger, which of course is what you'd want to use during a testing mode or demonstration mode. But you can also select a camera trigger or a manual trigger, or if you're triggering from a PLC, you would select the real-time Ethernet trigger. Next is to determine how the Insight 2000 will manage the lighting. As you know, the Insight 2000 has the built-in very high bright diffuse light. Well, how is that light going to illuminate the image? You have two choices: auto exposure or manual exposure. In auto exposure, the Insight 2000 will dynamically adjust the exposure value after every acquisition to achieve a fairly constant brightness, which you can control here. In manual exposure mode, you set the exposure value, and every image that's acquired will use that exposure value and use that particular light intensity. So I'm going to use auto exposure for the rest of this video. You have a couple other features over here. One is the image area height. So if you'd like to minimize the number of rows that are acquired, you adjust that here. And why would you want to do that? Well, if you have a feature that is very consistently presented within a particular range of rows in the image, you can significantly speed up the acquisition time by limiting the rows that are actually acquired. For this video, I'll go ahead and leave that at the default, so we're acquiring all 480 rows. You also have an image magnification mode, and this is pretty cool. When you enable image magnification mode, the field of view is cut in half, but the optical resolution is doubled. So you'd want to use this when you had a fairly small field of view application and you needed the highest resolution possible. You enable the image magnification mode. I'll leave that disabled for this video. And I need to adjust my target brightness here, so I'll do that. And I think we're ready to go ahead and begin our inspection. So I'll click on the Locate Part step. So when you click on the Locate Part step, you immediately see a list of location tools down here in the lower left. The list of tools that you see will vary based on which model of Insight 2000 you're connected to. I'm connected to the Insight 2000-130 model, so I have all of the location tools available to me. That includes pattern, edge, edge intersection, and circle. And you notice as I click on a tool, you'll see a brief description off to the right. That's particularly useful for new users. Now, what all these tools have in common is that they're designed to be used as fixtures for inspection tools, other inspection tools that you'd like to add to the job. Of course, these tools by themselves can also be the inspection that you'd like to perform. But for this video, I'm going to fixture other tools off of a pattern location tool. So I'm going to go ahead and click that pattern and click Add. And immediately you'll see that there's a region of interest on the image. Now all of the tools behave this way. So that's part of what makes EasyBuilder easy. So I now have a region here that I can adjust just by clicking on it. It's very interactive. In this case, it's a pattern tool, and I'd like to search the entire image for my pattern, so I'll go ahead and leave that there. I also have a different region here for the model. I'm just going to put that around the Cognex logo here so I can train a pattern. And then I click the OK button. And right away you see that there's now finally we have a result in the Results tab, and it's the result of the pattern tool that I just added. And of course I haven't changed the image at all, so it just passed. And you know that it passed by the green indicator here on the result for this tool, as well as the text in the result column here that says that it passed. Now I can make adjustments to the tool, and I can do that just by clicking on the slider here. This particular one changes the rotational tolerance for the model that I just trained, and I can also adjust the accept threshold for the model that I just trained. You see the model over here on the right. I can give this tool a logical name. I'll go ahead and call this Find Logo. And all of the tools that you'll add to an Insight 2000 job have the capability to have a meaningful name, and you can also add a description. Once I give it a name, you'll see that the name now appears in the Results tab, so that if I have several tools in my job, I know what they do because I gave them a name that meant something to me. Now here's a really cool feature that we just added to Insight 521, and it's called the repeating trigger. Click the repeating trigger, and what's nice about this is that I can now adjust, or I'm sorry, I can move the part in the field of view, and the inspection is taking place as continuously. I don't have to go online. The 2000 is not responding to I/O. This is strictly just running the tools on the images as fast as it can. I can even change the parameters of the tool while I'm in this repeating trigger mode. Now I've got my full 360-degree search. And as I rotate this poker chip here, you see that the pattern is still being found. In this case, we are using the pattern match tool is PatFind, so it's fairly robust. We've had it for quite a long time, but it's a very reliable performance tool. All right. So clearly we can find this part very reliably. Go ahead and get that back in the center of my image here. I'm going to take it off of the repeating trigger mode. Now that we have a reliable location tool, we can add additional tools to the job. And I'm going to click on Inspect Part step, and we can begin. When I click on the Inspect Part step, I see a different list of tools down here in the lower left. Now this list of tools will vary based on the Insight 2000 model that you're connected to. I'm connected to the highest end Insight 2000 model, the Insight 2000-130. So I have all of the Inspect Part tools that are available on the 2000 series available on this model. If I was running a Insight 2000 dash 110 or dash 120, I wouldn't have the edge tool. I wouldn't have the circle tool, the measurement tools, or the counting tools. I'm going to go ahead and add our first inspection after the finding the logo to this job file. I'll select the pixel count tool. And again, immediately you see a region of interest that can be positioned over the feature that you care about. In this case, I want to count the number of black pixels that comprise the chip stack here. If the count of the black pixels is within my minimum and maximum range, then I know that these chips were printed correctly. So I'll go ahead and position that region. Now, before I click OK, there's a region type control here. If I click on that, I get a list of the regions that are available for this control. Again, this is typical of other tools that are available with the 2000. In this case, I could choose a rectangular region, which is the default, a circular region, an annulus region, or a polygon that I would create. I'll just go ahead and accept the default rectangular region. And you see right away that the pixel counting tool has been added to the job. This here in this column, this chain column, indicates that the pixel counting tool is dependent on the Find Logo tool, this pattern matching tool that I just created. And in fact, the pixel counting tool is fixtured to the Find Logo tool. Now, what do I mean by fixturing? Well, let's go ahead and click on the repeating trigger icon there. And I'm going to move the chip around in the image. Now, ignore the pass-fail on the pixel counting region, but notice that the region moves along with the logo. That's what we mean by fixturing. The position of this tool, the pixel counting tool, is relative to the position of the logo in each image. Now, the pass-fail parameters, the reason that I'm failing here is in the pixel counting tool is very sensitive to changes in the brightness within that region, and of course my fingers are adjusting that brightness as I move it around. So let me go ahead and I'll stop this here, and I'd like to make that tool just a little bit more generous, the pixel counting tool, and I can do that just by adjusting the minimum and maximum slider here. Now as I move my chip around, you see it's a bit more robust, even though my fingers are adjusting the intensity of the image within the pixel counting region. Now I can add any number of inspection tools to this job. In fact, I'll add one more, but before I move on, what I would like to do would be to name this tool. I'll call it Check Chip Stack. So now in my results, I'm finding the logo, I'm checking, verifying that the chip stack is present, and I can move on. First I have to take it out of the repeating trigger mode. Now, I already have a pattern match tool, finding the logo, but now let's say I'd like to perform an additional inspection, which in this case would be to find the horseshoe, verify that the horseshoe is present. So I'll add another pattern tool. This time this is under the presence absence list in the tools. So I'll just add it here. Again, I've got two regions of interest. One is for training the model. That's what I'll do with this region here. Train the model, the horseshoe. And because this tool is going to be fixtured off of the logo, I can afford to make it fairly small. So that's what I've done. Click OK. And now I've got a new pattern tool that's also dependent on the Find Logo tool. Again, this indication here shows that the pattern tool is dependent on the Find Logo tool. And I'll name this Find Shoe. And you see that name here in the results. I don't need to specify a large rotation tolerance here because this tool is fixtured to the logo, and so it'll move around as the logo moves. Go to the repeating trigger, and you can see both my pixel counting region and my Find Shoe region are tracking along with the logo. So this is essentially how we expect that most Insight 2000 applications are going to be. You're going to have a part locate part tool followed by one or more inspect part tools to perform these simple presence absence type inspections. But notice that each of these tools is outputting its own pass or fail. So that takes me to the next step, or rather the next tool that I can add to a typical job, and that would be a logic tool. Now with the logic tool, what I'd like to do would be to consolidate the individual tool results into an overall pass-fail. So I select the logic tool, which is all of the Insight 2000 models have this tool. I'll click Add. And I have a logic tool here because that fails because I haven't added any logic. You can see that up here in the corner here. Let's go ahead and construct a very simple string to get our overall pass-fail. So for each of the tools, I simply have a fails condition and a pass condition. I'm going to determine or define the pass condition here. So check chip stack pass, or rather, let me start with the logo. So if I find the logo and the check chip stack tool passes, and I can find the horseshoe, then this inspection will pass. I'm going to give it a name. I'll call it overall result. And there it is in our results list. This is the overall inspection result that I can return just as a single pass-fail for all three of these tools, or I can also output individual tool results for a more granular pass-fail if that's something I'm interested in tracking. Let's go ahead and put this back into the repeating trigger. And you see your overall pass-fail result in the results list, and also the string in the upper left part of the image here shows overall. Now, if I obstruct this image in some way to cause, well, say the chip stack inspection to fail, you see right away the overall pass-fail turns into a 0. That indicates a failure. Now, I'm finding the logo just fine, and I'm finding the horseshoe just fine. But because I've now required that all three of these inspections must pass, the overall result fails. Or here's another example. I'm going to flip this chip over, and now you see that we're still finding the logo, and that's because we'd specified that the logo could be, we search for the logo in a full 360 degrees of rotation, but I'm finally finding, I'm not finding my two chip stacks, or at least I've got one, but the pixel count tool fails because there's only one chip stack. And the other pattern tool is, it's not finding the horseshoe. There's some two die in there, and there's no horseshoe, so this inspection will fail. So that's let me flip this back over here to get a pass, and now we're back to a passed inspection. So this is, again, a very simple example, but that's what the Insight 2000 is designed to do, this type of inspection. But at this point, I can see what my pass rate is, and I can see how many inspections I've performed, and I can see the time that's being performed here, but I'm not actually outputting a pass-fail result. So that would be our next step, would be to configure the inputs and outputs and communication. So now I'll select the inputs application step. And when I do that, you see there's only one line here in the inputs, and that's because the Insight 2000 only has one general purpose discrete input. For the acquisition trigger, that's selected up here in the setup image step in the trigger drop-down list that I showed earlier. For the general purpose input, there's really three states. There's only three states that you can configure this as. One is user data. Now when you have user data selected, that can selectively enable or disable the tools here that's configured back in the tool setups. Or you can reset the inspection counters, that's right here in the bottom of the results tab. Or you can take the 2000 sensor online or offline. Let's go on to the outputs. The Insight 2000 has 4 discrete general purpose outputs, each of which is represented as a row here. For each of those outputs, you can choose how you want to, what you want to output. You can output the individual pass or fail for each tool in the job, or you can output an overall pass-fail. There's also, you can also configure the indicator LEDs that are on the front of the unit and set those up for pass and fail as well. Moving on to communication. So with the communication application step, this is where you set up how to send data out over Ethernet or over serial to remote devices. I'm not going to go through all the details here, but you can add a device. In this case, I've added an Ethernet IP device, and that Ethernet IP device can be used for both inputs and for outputs. So I've got on the input tab right now. If I select add, I can choose to actually, from the PLC, I can choose to change the parameter of the tool. So that's one possibility. And then on the output side, I can also format output data. Again, my inspection results, I can output the details of what's being used to acquire the images, or the individual pass-fail for the tools, or an overall pass-fail for the tools. So I know this is very high level, but you'll get more information on this in training, and of course you can get information in the Insight Explorer help file. Okay, now I'm going to skip ahead to skip over the film strip step. I'll come back to it in a moment, and go to the save job step. So this is, as you might imagine, where you can save the job that we just created. Now I've already saved it. You can also choose the startup job for the Insight 2000. So I've saved this job as the demo job, and when I select it here, and if I were to click this box, now whenever the Insight 2000 powers up, it's going to load the job that I saved, and it's going to load it in online mode, ready to go, ready to start performing the inspection. You can also choose to back up the entire system, including the job files that are stored on it, or you can restore from a backup to recover the job file that was known to be good from a previous date. Let's go right to the run job step. So this is the last part of it. In the run job step, you have the option to place the system online. Of course, you can always click the online button on the toolbar as well if that's exposed. You can clear the pass-fail totals, so we're starting from scratch here. And you can also configure what information is displayed here in this section at the end. So I'm going to go ahead and put the system online, and we still have our inspection job, and you see the difference between what's down below in this area versus what's over in the results tab is that you get individual pass-fail statistics for each of the tools, and also you get the individual times for each of the tools. So now you can determine which tool is taking the most time and perhaps do some optimization. And you see in this case I have a Find Logo tool that's taking the bulk of the time. If you recall, I also set that tool to search in a full 360 degrees of rotation, so that's where that time is coming from. Now I said I was going to show you the film strip step, and that'll be the last part of this video demonstration here. So let me go back to that. Now the film strip allows you to display, just as it says, a film strip on the image at runtime. And on that film strip you can choose to display all the images or just the failed images, which is the typical case, and also pass images. You select where those images are stored on your PC, and then the last thing you need to do is to enable the film strip, which is done off the view menu. So I click film strip off the view menu, and I've got failed results, so I only want to display on the film strip the images that fail. So I'm going to put it back online, and now I go back to here. I create generate some failures, and notice that the system is, while the system is still online, I can click on an image in the film strip. I see the image that failed, and I also see the results of each tool as of the moment of that failure occurred. And I can continue to click through these. Now there is a little bit of performance hit on the 2000, so not everybody will want to do this, but it's a very useful feature if you want to analyze recent failure history without taking the sensor offline. So let's get back to our normal operation here. I'm going to clear the film strip out, and you see we're running the inspection just fine. This concludes the walkthrough for Insight Explorer 521 and EasyBuilder interface for Insight 2000 series vision sensors. As I said at the very beginning of the video, this isn't intended to be a detailed product training, rather just a high-level overview. I hope that you found it useful. You'll get a lot more information in the product training and in subsequent e-schools to come. Thank you for watching.